So I have good news about this question. This is actually a very easy question, but it's disguised as a tricky question. It's asking about the molecular weight of a hypothetical gaseous compound. So we know some things about gases. You can see down here, I've got the ideal gas law. And I'm going to run through this real quick just in case. The ideal gas law says PV equals nRT, or pressure times volume, is equal to moles times temperature times the ideal gas constant. Now, pressure and volume can be given in these units here, atmospheres or torr or kilopascals or millimeters of mercury. It's important to note that torr and millimeters of mercury are the same. Liters or milliliters for volume, and temperature, degrees Celsius or Kelvin. Moles are obviously always in moles. The value for R is one of these numbers, and there's actually plenty of other ideal gas constants. These are the three that I think are the most common. And in fact, you're probably most familiar with this first one. This is the most common one taught in chemistry classes. It's the units of liter atmospheres per mole Kelvin. The trick with R is that when you're using it, you need to make sure your units match. So in my explanation, I'm going to use this value for R, 62.36 liter torr per mole Kelvin, because I've been given a pressure in torr, and so I can just plug that in. But if you're unfamiliar with this constant and you'd rather convert it to atmospheres, I've shown that in my work as well. And so what do I mean by this is an easy question? Well, it's asking for the molecular weight. Well, what is molecular weight? Well, molecular weight of a compound would be something in grams per mole. So that means in order to get molecular weight, I need grams and I need moles. So I need to know how many moles of something I have and the mass of that thing. And this is where people mostly get tripped up on this question, is they don't realize that they can use any mass of some number of moles to get the actual molecular weight, because the molecular weight is a mass of just 1 mole. If I had 2 moles, the molecular weight would be doubled, but the ratio is the same. So that's where this trick comes in, is not understanding that. So let's walk through the problem quickly here. It described, and this is all the information that was given, the mass of this flask, is 105 grams exactly. And then when we added gas to it, the mass of the flask went up to 105.958 grams. Gave us a temperature of 22.3 degrees Celsius. The pressure of the gas is 500 torr, and the size of this flask is 250 milliliters. And now we just discussed that molecular weight is grams per mole, and this is the key to getting this problem. Also, we're going to need to use the ideal gas law. So first, let's find how many grams of gas I have. That's just going to be the mass of the flask plus the gas, 105.958 grams, minus the mass of just the flask with nothing in it. It was in a vacuum when we measured this, and that's 105 even. So that's a simple subtraction to give you 0.958 grams. That is the mass of this gas. Now, if I can figure out moles, I can get molecular weight. Well, fortunately, we can rearrange the ideal gas law to solve for moles. N equals PV over RT. And now this is where I just plugged in my numbers. I plugged in my pressure of 500 torr. I plugged in my volume of 0.25 liters. Now notice I did convert my 250 milliliters to liters. There's the conversion if you're confused there. I used this constant, liter torr per mole Kelvin, so all my units are going to cancel. And I converted my degrees Celsius to Kelvin as well. Don't forget that step. You can see that conversion up here as well. 22.3 degrees Celsius is 295.5 Kelvin. So we just plug that into the ideal gas law, and I get 0.00678 moles of my gas. Now, if you didn't like torr, and you took your torr and you divided by 760 to get 0.658 atmospheres, and instead use that for your pressure, and you use a different value for R, of 0.08206 liter atmospheres per mole Kelvin, you get the same answer. So it doesn't matter which one you use. So it's just up to you which one you find easiest. But anyway, we've got moles and we've got grams. So the molecular weight, or molar mass as I like to say, is going to be grams divided by moles, or 0.958 grams over 0.00678 moles. And that answer is 141 grams per mole. Now realize, by the way, this per mole That's per 1 mole. So all we've done is just readjusted this ratio to be in terms of 1 mole. That's all a molecular weight is, and that's why this question can be tricky.